My name's Mark Hinkle. I am the um, co-founder of all things OpenAI with my partner here, Todd Lewis. Um, and Todd is also, as I said, the founder of All Things Open, big open source advocate, done a great job building communities. And today, we are fortunate to have with us BJ Hargrave from IBM, and he's going to talk about building open source large language models. So I am going to just let him start out, introduce yourself, and hit the road running.
Sure. Hi, everyone. My name is BJ Hargrave. I've been around for a little while, as you can tell from my color of my beard. I've been working with IBM for quite some time and most recently involved in AI model stuff inside of IBM research, and in particular, the Granite family of AI models, which is what our talk today is going to be about. So let's dive right on in and see how it goes. I'm going to start off initially by just going through some charts to try to position Granite in your minds relative to other AI models that exist out there, and try to point out some of the sort of what IBM thinks are unique and valuable propositions around Granite, especially in the enterprise space, not just your general consumer who wants to ask a question into a chat app. So when we're talking AI, there's a lot of parts in the story, right? There's models which are trained on data. These models have to have governance to make sure we understand what data they were actually trained on. And then people write things around models like assistants or agents. And so today we're mostly going to be focusing in on the model side of things, right? There's lots of other things to say about those other parts, but that's not what we're going to talk about today. Today we're going to talk about models, in particular the Granite models. So, like I said, there's many models out there, right? Of course, everyone knows ChatGPT. It's basically the Jello of AI models these days. But basically, it's one giant model trained on lots of potentially questionable data, and so it can be interesting in some scenarios and not very helpful in other scenarios. Mostly because it's a closed model, right? You can't run the model yourself. If you're in a business, you might have regulatory requirements about your data that you need to run models in-house in order so that the data you send into the model and the data you get out of the model is properly controlled, right? So basically, not all models are appropriate for businesses at the sort of data control level that they need, and also at the size level that they need, right? ChatGPT is very expensive to run. So basically, these are sort of questions to ask about, your model. Is it trusted? Is it open? Does it perform well? Can you customize it? Is it efficient? And is it flexible? Right. So if you look at some of these other models like ChatGPT, you don't really have, it's not open. It probably performs pretty well at a high level of cost to run it. Right. So it's not necessarily super efficient. You can customize it in some strange ways, but it's not at sort of at the base model level, and it's somewhat flexible, but you can't do the same sorts of things you can do with a model that you can run right in your own enterprise. So this brings us to why IBM came out with Granite as a family of models. So basically, one of the things about Granite is it's not just a language model. There's some other aspects to it as well. We'll talk a bit about those. But basically, some of the key attributes, right? One is it's open, right? So the Granite models are available under the Apache 2 license. IBM has very carefully curated the training data that we use on them, so that we try to avoid sort of copyright infringing training data and things like that. And of course, because it's a modest size model, it's sort of reasonable for you to consider fine-tuning it with your own data, and because it's open source. It performs well for its class of models, right? Not everyone needs a 600 billion parameter model. Sometimes, 2 billion parameters is enough. or 8 billion parameters, right? So we've got this family of models, and they have different scale points. We've recently introduced some new features such as reasoning, sort of chain of thought prompting. You can turn that on and off in your request to the model so that it acts accordingly. So, because sometimes queries are pretty straightforward and don't need to be reasoned. Other times you want to see the chain of reasoning that led the model to the answer. And we've also recently added some vision capabilities, basically where the model, the Granite model, can understand an image and extract useful information out of that image as sort of an image to text mode of operation. And of course, because IBM put a lot of thought into the data that we use to train Granite, you can consider it a trusted model. We offer IP indemnification for that. We also support some guardrails. So we have the Granite Guardian models, which are useful to secure sort of the use of your AI model around checking the inputs and the outputs to sort of secure what's going on with the model and mitigate risks. Right. So in the sort of family of models that are available, right, we've got large language models, which of course are the sort of classic workhorses here, right? So we got the Granite, recently 3.2 models. As I mentioned, we came up with recently with a vision model. We've also got some mixture of expert models at the moment. They're very small, designed for sort of very close to the edge AI inferencing, because they basically have a large amount of weights, but for any particular inference call, only a subset of those are activated for efficiency. We've got some guardrail models, which basically you can use on the inputs and outputs to another large language model to vet the inputs to see if someone's trying to jailbreak the model, or to examine the outputs to see if the model accurately answered the query or is just hallucinating. Sort of very popular part of the family is our time series models. Granite has some models which we can do sort of forecasting and other things on a time variant data series. So this is quite popular lately. We get a lot of downloads, people using this at Hugging Face. IBM's also got some embedding models, right? If you're building any sort of RAG application, one of the things you have to do is take your data and put it in a vector data store. So we've got some super efficient and small embedding models for Granite, supporting English only or multi-language if you need. And some more specialized stuff, we've got a speculative decoding models, which basically sort of, in order to get fast time to results, they will speculatively decode in the hopes that they are on the right track. If you ever work with CPUs, you understand what speculative instruction decoding is. It's sort of in that same vein. And we've got some geospatial models, and we've done some work with NASA on these. So basically across this family of models, right, we've added some reasoning capabilities. We've got now multimodal capabilities, in particular vision. We're looking to expand that in future releases. We basically have trained these Granite models over 12 trillion tokens of training data, including 12 different human languages and 116 programming language. And of course, these are open models, right? They're available under Apache 2. You can do with them as you see fit. So in an enterprise scenario, there are several sort of classic use cases. We'll touch on a few of these as we go through some of the labs in the Granite workshop to let you get some experience using them. Of course, very popular now is agentic workflows. So we've got a couple of recipes around that. We've also got a very nice Granite retrieval agent, sort of more complete example of doing agentic workflows with Granite. These are all available through the Granite community. I'll talk about that in a bit as well. And then, of course, you got your classic language-based tasks like RAG, summarization, extraction, classification. Granite has some code models, and we're continuing to expand the code support in the language models. Granite is sort of the underlying engine for some of IBM's Watson Code Assistant products that are available. I mentioned we have the time series stuff, which is very popular and people are looking at that. We've just come out with a new recipe on retail sales forecasting using the time series model. Geospatial is a bit more nichey, but it certainly is interesting if that's your niche. And then the Granite Guardian stuff with safety and other things around using AI models in a safe and reliable way. So in the family of models, right, if you go up to Hugging Face, if you're familiar with that, right, we've got the IBM Granite organization up there, and that's where you can get all of these models. For those of you that want to run them locally, we've just started publishing official IBM GGUF conversions of these safe tensor models. And that's up on Hugging Face also under the IBM, I think, research organization. So you can get GGUFs directly now from IBM. So there's a whole bunch of different size models here, right? In the language models, we've got 2 and 8B available, as well as these mixture of expert models. There's the A400 and A800M. Those are the millions of parameters that get activated on any particular invocation. A series of Guardian models around safety and guarding the inputs and outputs to a model. The accelerator models are the speculative decoders. We've got our new vision model that just came out, and I put together a example of using that in a RAG situation, which is up on the in the recipes list up on the IBM Granite community. We've got a variety of code models of different sizes, a family of time series models, depending upon what it is you want to do with time series, and then, of course, our geospatial model family. So that was basically just to try to give you an overview and a positioning of how Granite is, fits into the larger universe of AI models, right? It's not intending to be a giant model that solves all problems for everyone. It's really focusing on some use cases that in particular are interesting in enterprise at a scale point that makes sense for their use in those scenarios, as well as basically being open, an open source model, which let you deploy it yourself internally if you have those sort of needs regarding data sovereignty, or whether you want to run it on a cloud provider such as watsonx or Replicate. So it's a nice family of stuff, and I hope you check it out. So next, let's talk about the IBM Granite Workshop in the context of the IBM Granite community. All right, so let's go back to the browser.
Before you get started,
Oh, yeah.
BJ, I just want to point out so that people understand that there's sort of a lot of talk about open models, and this is why I thought it was important that we had this presentation, is that there's the open source code, but the thing that's really interesting about Granite is that you have a data training bill of materials. So you see where the data is. So we see, all these, like, Adobe got caught not too long ago saying, oh, we only trained on our data, and then they found out it was trained on Midjourney's data. OpenAI is in litigation with the New York Times about training on their stuff. So the safety and the ability to use the model internally and have a good trusted source is good. And IBM has been a good shepherd for open source. I'd also mention that Mark Zuckerberg thinks his model is open source, and there's some conditions around it that are not consistent with open source standards. Like, you got to register, give your birthday, your organization before you can download it, which they say is due to export restrictions, but then their license is a little wonky. So just for everyone here, I think it's really important that if I was running a huge business, and I used to do that, I would really consider Granite. And I would say that even if, BJ's weren't our sponsors. But and the question Olivier had is the weights are open as well. So it's weights, data, and the code. Is that right, BJ?
Yeah, the weights are open and it's available under the Apache license, as I mentioned. Now, the actual code to train the model and the actual data to train the model, we don't make that available as open source. I'm not sure that we have the rights to all the data anyway to do that, but we do provide a description of the sort of the data sets that we're using, so you can see what kind of data is going into the model. But we don't actually provide the actual data sets in open source.
Yeah.
Right. So
Yeah.
this,
And
I think,
that's,
gets to sort of a bigger question. What is an open model in today's world, right? And so there's a camp that says everything is open, everything must be there. I should be able to reproduce this entirely, versus the sort of the model openness framework kind of situation that LFAI is promoting, which is more nuanced in terms of what's practical in the real world today.
yeah. Thanks. I just thought that was important. So go ahead.
Sure. Okay, so we created the IBM Granite community, which is basically it's a GitHub organization, and they're trying to give information to the community and in particular to developers about using Granite. So we have a variety of sort of cookbooks. So we have our snack cookbook, which is sort of snack-sized recipes for using some of the Granite models. And then we have some more focused cookbooks, in particular like the time series cookbook, which has a bunch of all time series oriented recipes. We're looking to build out our prepared meals, which are sort of larger stories around Granite. So this one we have is the agentic use. So it demonstrates an application using a bunch of popular open source projects around AI and agentic stuff, agentic use cases, and using Granite as the actual model to operate the agents. So I would check that out too if you have a chance. And so what we're going to look at next is that we wanted to put together sort of a curated set of recipes that one could sort of see the breadth of the Granite model family and basically get through them in some reasonable amount of time. Right. And so that's why we came up with this concept of the Granite Workshop. So we have another Git repo here, the Granite Workshop, where basically we have, with fairly detailed directions, a curated set of these recipes that you can use to sort of learn a bit about Granite, how it's used as a developer, and explore some of the space around that. So we're going to spend a little bit of time going through that now. So it basically, you can come in here and see the workshop, and we've got a recipe on text summarization, one on using RAG techniques with Granite. We've got a time series forecasting using some weather data, and a little bit of code programming with Bash using the code model. So the workshop is pretty detailed. There's some pre-work you can go through. And so one of the things as we put together this particular workshop, we realized that there's a rather broad skill set of people that might be interested in learning about this, right? There are some people that are hardcore developers. They're going to have 12 versions of Python installed on their system, and they're good to go. But there are also going to be some people that just do not have Python installed on their system. And so we have a couple of options depending upon how sort of interested you are in running things locally on your system versus taking advantage of some services that are out on the internet. So basically, this can broadly be thought of as you can run the notebook on your computer, or you can run it remotely on Google Colab. And so it really depends on the kind of person, kind of laptop, desktop situation you have running, right? If you want to run it locally, you've got to be able to install Git and Python and Git clone the workshop down onto your desktop. You can also run Olama to run the models locally. As I mentioned before, we now have official GGUF variants of the models available from IBM, and those can be are available also to download through Olama, or you can install them yourself in a local Olama setup. So basically, the other key thing is, where does your model run? As I mentioned, you can use a Llama, but we also support the Replicate AI cloud platform. It's one of our launch partners when we came out with Granite. And Replicate's sort of nice in that it provides a hosting situation for different models. You can see, there's a bunch of models here. That IBM has up. We have the Granite 3.2 Instruct model. We have our Vision model, as well as some of our older models and available up there as well. So this gives us, we can put these models up there, and it makes it fairly easy for people running these notebooks to get access to the model. It's pretty straightforward to create a Replicate account. All you really need is a GitHub account to do it. And then once you get up there, there's a nice little link you can click on. We'll give you a few cents of credit, which is more than enough to sort of run these examples. And then with a Replicate API token, you can just add that to your environment before you run the notebooks, or stick it in your .env file, something like that. Right. So, like I said, there's lots of options here for how you want to run it. So today I'm going to actually break the rules, and I'm going to use VS Code as my Jupyter Notebook environment. Since it's sort of how I develop many of these recipes, it's nice in terms of being able to debug them and experiment with them since you're in a code editor. So let's go take a look now then at some of these labs in the workshop. Okay, so this is my VS Code setup. I've got a bunch of different Python extensions installed in it, which really makes it quite productive and useful to do sort of notebook execution and development in VS Code. And so this one is the first one we're going to look at is document summarization. Now, of course, virtual environments are key for not pulling all your hair out when using Python because of the Python dependency hell. So in this scenario, I've already pre-populated a virtual environment. I've set it up with Python 3.12. And so you can confirm that we got the right version of Python that's understood. Some of the versions of Python here are mostly about some of the dependencies we care about, whether or not they support certain versions of Python. In particular, in the past, one of the challenges has always been PyTorch, because it tends to be somewhat sensitive to versions of Python, certainly with respect to Torch compile. And of course, like any good Python program, it has dependencies. And so we provide a set of some simple methods and things that we use in most all of our recipes. So we install that. And a lot of our recipes, including this one, are users of LangChain as a sort of common library that makes it easier for us to substitute in different providers of the model. And in fact, here we're going to show you how we do that with the Llama. And we install dockling, which was an important part of some of these situations, some of these recipes. And we'll talk about dockling when we get there. So of course, the first thing is replicate, right? So if you are using a Llama, you need to get your Llama server up and running. If you're using replicate, you need to make sure that you have a replicate API key and that you put it into your environment. Or if you get to the point where it asks you the question, it'll pop up a little dialog and you could enter it there. But I've already got it added to my .env file, so I'm going to be good there. So then the next thing we need to do is load a model, get our model ready to use, right? And so in this example, we have two choices, right? We can either use a Llama. And so the code here basically says, is a Llama server running? If it is, then we're going to use a Llama. If it's not running, then we're going to fall back to replicate. So in this scenario, I do not have the Llama server running, so we're going to end up using a replicate to access the model. And of course, we have a few arguments for the model to use. So we'll run that baby. And that's pretty quick. All right, so our example here is going to be summarization of a big document, a document bigger than the context size of the model. All right, the Granite 3.2 models we're using have a 128K context window, but I think this particular document is like, over 600,000 characters. I think it will far exceed the context size. So we're going to need a tokenizer here. So we're going to pull down the tokenizer for the model because we need to know how much we can feed into the model. So we want to understand how big if our chunks are within the context window we've got on the model. And then we get into using Dockling. So Dockling is a really cool open source project that IBM Research had put out, which basically it's about understanding different formats of documents and how to break them up into parts. Right, so in this Dockling is nice. It understands PDFs and HTML, which are kind of most of the things you can find on the internet these days. It understands how to ingest them and reformat them into an internal representation, a Dockling document. And then from that, you can do lots of manipulations on it, including doing embeddings for RAG and that sort of thing. So Dockling is very cool. We use that in a number of our recipes. So I would encourage you to check that out. So all of this complicated code here is basically just going to take the document we download and chunk it up. It's going to use a hierarchical chunker, which means it understands sort of headings and what they mean in terms of this is a chapter, this is a section of a chapter. We're going to throw away some front matter and some back matter and end up chunking at the H1, H2 chapter heading level. So we decide that H2 is their chunk point for the document. And so this will pretty quickly download that document, go through the process of chunking it up into a series of documents, and tell us how big our biggest document is in terms of tokens for the model. Right, so it basically took this downloaded file from this HTML file from the internet, which is a HTML version of Walden by Henry David Thoreau, but it's got some front matter. We don't necessarily want to parse this stuff, and we don't. And there's another little book at the end. We just want to focus in on the core document here. And so we basically broke that down into 18 chapters. And of course, the biggest chapter is 38,000 tokens. So now we want to write a little method to go through that. This is pretty straightforward. It basically uses the Granite chat template, which is important to get good results from Granite, right? It's trained with a special chat template in terms of roles and sort of special symbols involved. So I always try to use the chat template to get the best results. And this also supports passing documents in to the chat template. So it formats them in a special documents role into the prompt. And so then we basically can grind through the document, taking each chapter in, passing it into the model, and letting the model digest it. So you can see for each chapter, there's a big input size, which is the chapter contents, followed by a more modest summary of the chapter. So we've got 18 chapters to go through here. It goes pretty fast. And then, of course, once we've summarized each individual chapter, since each chapter fits within the context window of the model, now we need to create a unified summary, and that's sort of the final step. So we take the chapter summaries and we ask Granite to summarize the summaries. Right, so we give it a nice prompt that says basically using only these book chapter summaries, create a single unified summary of the book. And so we get 18 summaries generated, and now we're going to ask it to give us a final summary. And then I will leave it to our English majors here to tell me if this is a good summary of Walden. Seems pretty basically on track from my point of view, being a computer science major. Okay, so that was summarization, right? So that's a classic scenario that you need to do in some enterprise situations. And so that basically showed how we could use a small Granite model and summarize that data, right? So, for example, you can imagine instead of being sort of a work of literature, it was a corporate PDF with some processes, and you wanted to digest this, a bunch of these sort of things. So you can use this model in-house to process and summarize sort of proprietary corporate documents.
And before we go any farther, we have a couple questions,
Sure.
BJ. Well, one thing I just wanted to weigh in on the chunking. The reason that you chunk data is because there's a certain size of context window. Is that right?
That is certainly one of the main reasons to do it, yes.
And how big is the context window in Granite, this model particularly?
So the Granite language models have a big context window of 128K, but it's
Okay.
not without cost, right? So for example, here you'll see that if we were going to use Olama, I was going to set the context window at 64K because that was more than enough to do this job, but it didn't have to reserve all the memory necessary to hold and process a very large context. So basically, as the amount of context you use goes up, right? The amount of memory needed to run an inference pass and the time it takes to execute that inference pass goes up as well.
Okay. And we had another question. When you were going over how you were deploying the models in Olama, what, a lot of people can do that on their desktop, but do you have any anecdotes about deploying Olama for production uses, or what's the answer? We had a question from Kane that was.
Right. So one of the valuable things about Olama is this local execution. So if you just, experimenting with the problem, you can run it right on your laptop with Olama. I don't, of course, that is made possible generally because what we do with these by default, like that Granite 3.2 2B model that's shown there, that is not the full size, F16 floating point 16 model, right? It's a quantized model, probably Q4. And so that basically makes the model smaller. So it fits on smaller systems like your laptop. And it makes the model run a little faster because the math calculations are smaller. But it can impact the outputs of the model, right? So it's great for experimenting. And if the results are accurate enough for you, that's fine. But in terms of a real deployment, you probably would want to really deploy the model at its full size and capacity.
Okay. Um, Another question is there a relationship between context window size and memory requirements? Is it linear, exponential, or something else?
I'm not sure. It definitely is proportional. I just don't know if it's two times or four times. But that's one of the reasons. So one of the interesting things with Olama is by default, regardless of what the model's context window, Olama will use a 4K context window with the model, unless you override it with, for example, like I did here with the num context. You can override it in several other ways too. But if you are experimenting using a llama and you're trying to do prompts that are bigger than 4K, make sure you set the context length big enough to handle what you're trying to do. Otherwise, a llama has this unfortunate behavior of just truncating the prompt until it fits into 4K. So it basically just silently discards part of your inputs, which can mean things like summarization don't work well because it doesn't see all of the data you're trying to summarize.
Yeah, and I will also add that right now we're all seeing NVIDIA and GPUs being a hot commodity and people trying to get them. The other thing that's next is probably DDR3 RAM is going to be the next shortage because we'll need more memory to do that. So while we don't know exactly what the
Mhm.
relationship is, memory is going to be the next frontier of hardware. Um, Miriam is asking for coders working on a repo, locally run model is probably sufficient. Is that true?
Yeah, I think so. In fact, one of the other demos that we've done with Granite too is showing how you can use it in VS Code as your personal coding
Mhm.
AI, right? So it's can be quite useful in that scenario, and that it's sort of super compact. None of the code ever leaves the system, but of course, it's not going to necessarily get as big a result, a good a result as a larger scenario where you actually use sort of larger models running off device. But it makes an interesting example of how people can do stuff sort of in an almost air-gapped way, using models on code on their laptop.
All right. Uh, what did you use? The next one was from John. What did you use for the chunking size? And
Right.
is it affected by context windows of the LLM?
It can be right. So in this example here, I just asked the hierarchical chunker to chunk the document, and then I told it to recombine at the H1, H2 level, right, where H2 represented the chapter. And so there's a merge chunk part here where we basically say if these guys have the same headings, then let's merge them together. Now it worked out, and I confirmed it with my print here that the maximum chapter was 38,000 tokens. So I knew that fit into my 64K context window that I'd given to Alama. So I was okay there. There also is another method you can use with the dockling. They have what they call a hybrid chunker, which is a wrapper around the hierarchical chunker, and you can tell it what is the maximum chunk size in terms of tokens, and it can use that then to sort of subdivide. If a chapter was, let's say, too big, then you could break it down into subchapters.
And now, when ChatGPT first came out, one of the problems was the context window was only about 4K, I believe, or 8K
Mhm.
for Pro came out. And so when you chunked up the data, it wasn't just about dividing it, but you sort of overlapped that data so it knew where stuff ended and gone. Is that still how it works?
Yes, I mean, Docklink can do that too. One of the arguments into that hybrid chunker I mentioned is that you can give it the sort of a max size as well as an overlap value, right? So you can have some number of tokens overlapping from chunk to chunk.
So Docklink supports that. Kane was asking. It looks like it
Yep.
does.
Mhm.
Uh, uh, and that's a limitation that he found with LangChain. So good for Docklink.
Yeah, no, Docklink is pretty cool. You should definitely check it out. I used it also in my, which we're not going to show today, but I have a RAG, a multimodal RAG example with images. And so I used Dockling to chunk a PDF into text and images, and then took the images and then passed them to the Granite Vision model to get descriptions. And then the text plus the image descriptions was the data that then got entered into the vector data store for the RAG part.
Yeah. So Rohanna also is asking, uh, they're looking to, um, I'm thinking that was a Python Dockling notebook as a service architecture and containerize it similar to the way that you do with WebSphere. Is that possible? Is that something that IBM provides? Um, I
Uh,
think,
I'm not
go ahead.
sure that we provide anything like that. I think you can certainly do it. I mean, Dockling is a library that you can use in your Python application to do sort of document understanding, understands the different formats. So to the extent that you could make that a service, that you could then pass it some document and it would return to you the chunks, I'm sure that could be done.
Okay. Cool. And then I think the use case that Rohanna was looking for is they have a client and they want to scale across hundreds of documents across their enterprise databases. So yeah.
Right. Yeah, I mean, so depending, I mean, if they're trying to take a bunch of these documents and chunk them so that they can then embed them into a vector story, yeah, you can certainly work out a way to distribute the chunking work since that's independent of the actual insertion into the vector store. So yeah, there's no reason, I don't see any reason why that couldn't be done.
Um, we have another question from Bertrand uh, that says, as a sysadmin, he needs to assist with deployments. He's working with the Linux 390X architecture. It seems to be a significant connection between the model and the system architecture. Um, he's asking about PyTorch and TensorFlow, and PyTorch and TensorFlow are open source libraries used for training. Um, can you deploy the Granite models on that architecture?
Well, I mean, PyTorch is a popular training library, and we certainly use it in IBM to train our Granite models for sure, right? We use a lot of features in there, like the fully sharded data parallel stuff.
Hmm.
Um, so that certainly can be used in terms of inferencing and running the Granite models. Like once you've downloaded it and you need to run it, there's a bunch of different technologies you can use. You can use the transformers library, VLLM. If you take the GGUF model, the flavors of the models, you can run those in Llama CPP or Llama. The bunch of other Llama CPP based offerings like anything LLM, all those sort of things can use that. So there's a whole bunch of options in terms of how you want to run the model. But we generally in IBM I think we use VLLM in our backends to run the model.
They're just the hits keep coming, BJ. How about the vision models? Have you had any experience doing scatter and dot plots with the vision models?
I have not. I just basically, my recent experience was just working on that multimodal RAG demo. So there's still more for me to learn about the vision models.
And then finally, the last one is there a publicly accessible reference architecture diagram for these use cases somewhere?
I don't know. Certainly, it's not a thing that we've worked from to develop these recipes. We basically, somebody has an interesting idea, we develop them. We try to highlight newer features that are coming in each release of Granite, like, for example, the vision support that was just added into Granite 3.2. As more features come in, we'll add more recipes to highlight them so that developers can, have a sort of quick and easy way to see how to exploit this new feature in their applications.
All right, we'll let you get back to it. I'm searching the IBM website. I see some product architecture, so I'll share it in the chat.
Okay. All right, so let's go on, I guess, to the next lab here, right? And this is RAG. RAG is sort of like the most popular, I think, use case for AI and enterprise scenarios. It's particularly important mostly because, even though sort of ChatGPT might have been trained on 99% of the data on the internet, it was trained on virtually 0% of the data in the enterprise. And so you need a way to have that information available to the model so they can do their job. RAG is a very popular technique for that. And so the basic, part of RAG is going to be to take the data, chunk it, embed it in the vector store so that when a question comes in, you can look up a series of chunks that you put in the embedding store, add them into the prompt as input, and then let the model synthesize that information into an answer to the question. So in this case here, we're going to be using one of the Granite embeddings models. So we've got English as well as multilingual embeddings model in sort of small and medium sizes. And so this is the small English model, which is all we need for this particular demo. We need a vector data store, so we're going to use open source Milvus to store our data. And then similar to before, right, the question is, where do we get our model from? We're going to go get it from Replicate for the purposes of running this today. So now we have a document, right? So in this case here, we're going to pull down the text file, which has the State of the Union address that was delivered, I think, in 2022. And so here's a document that we want that basically was something that happened after the end of the training cycle of the model. And so then we need to ask some questions of it. So, of course, the first thing we need to do is split into chunks. In this example here, we just use sort of fairly simple lang chain splitting, right? We didn't go all fancy with dockling here. So basically, we could character splitter. We use the embeddings tokenizer to tell us how big the chunk should be, because we want to make sure we can get a full embedding of each chunk. And of course, somebody asked before about overlap. In this example here, we're using 0 overlap, but you could pick a number bigger than 0 if you did want to have some overlap between the chunks as they're split up. And so this is going to basically take the document and it splits it up into 22 text chunks. We can then add these to our vector database, and then we can ask a question, right? So basically, what did the president say about Ketanji Brown Jackson? If we just ask the vector database, it returns 4 documents, which is the default, that are responsive to the query that we put in there. And so if you look through here, you'll see that the judge's name is mentioned in at least one of the documents. But of course, that's not very interesting. We want the model to give us a synthesized answer about that. So we're going to use a LangChain RAG pipeline. Now, of course, as I mentioned before, one of the key things I like to make sure people do with Granite is to use the Granite chat template. Right, so we're going to use the apply chat template method from the tokenizer, and we're going to pass it in some placeholders that are going to be replaced by LangChain later. And because it's a document that we're doing, we want to use the document support in the Granite chat template as our placeholder for the context of the documents. So we create a prompt template from that. We also create another prompt template for each individual document. So this is for each retrieved document, we want to wrap it up in a certain way. And so this is the way that Granite likes them wrapped up. A document with an ID followed by the page content. We then create our document and retrieval chain out of that. So that's all pretty straightforward. And then we can go back and ask that chain our question that we developed before. And so we'll go ask it. And then the answer is that the president nominated Jackson to the Supreme Court, and as well as some other descriptive information from the text. So that was sort of a very basic example of a RAG story using Granite and the Granite chat template and LangChain. All right, any questions popped up while I was talking about RAG?
I am looking right now. I found a reference architecture for what BJ just talked about. Also, here we have another question that Granite is not a frontier module. Could you explain how Granite is a frontier model?
So in my understanding, the term frontier model refers to the big giant models that are out at the leading edge of capabilities, things like ChatGPT 4.5 or Claude 3.7 or something. These are big, big, big models with, hundreds of billions, if not trillions of parameters, right? They're very expensive to train. They're very expensive to execute, right? So that to me is what I understand a frontier model to be. All right, it's on the bleeding edge. Whereas, not everyone needs that. Not everyone wants to pay for that. Some people can get by with smaller models that are more purposely scoped for the needs of the particular use case. And so in that sense, I don't think Granite really is a frontier model, and that it's not really aiming for that space.
Yeah. Yeah, I think that in the long term, these models will be pretty close. But right now, we see, the races between DeepSeek and Llama and OpenAI's models. So Carl's asking about Milvus versus other vector DBs. Do you have an opinion?
I don't really. I mean, that was just something that was picked up to use in this example. You can substitute the ChromaDB or whatever your other favorite vector database is. I know that LangChain has sort of wrappers for probably most all of the popular ones that people are using. So that's really a technology selection choice you can make and plug it into the RAG chain.
Yeah, Milvus is probably the most popular, or they were the most popular vector DB. And then Postgres now has vector extensions. But even Mongo, like a document store, they have what's called Atlas Search, that if you already have your data in one, you may be able to stay with your same vendor if that's advantageous. So like BJ said, it's open, so you can choose the parts that make the most sense. So I think you covered all the questions we had so far, BJ, so keep running.
Okie doke. All right. So let's go on to another recipe, right? So, one of the things in this workshop is we're trying to touch on some of the different capabilities in the family of Granite models. And so this is a nice simple example of us using the Granite time series model. So this example here uses some time series data that's available on the internet. So we basically can load up our code here. IBM provides a time series foundation model, public uh, set of libraries that can be installed from one of our repos. And this will basically pulls in most of the common things that one would use in doing time series forecasting. So it's pulling that down. And yeah, so the data set we're going to use here is from Hugging Face. It's energy consumption data that was collected in Spain at some time ago. And so that's going to be our source. Like in a lot of these sort of data sets, when you're doing your time series forecasting, you have to basically be able to tell the model um, what are the columns of interest in the data set that you want to use as the basis for your prediction, and what do you want to actually predict. The particular model we're using also has a context length size. So it'll take up to 512 data points as input to do the prediction. So here, basically, we're going to read all this data in out of our data file into a Panda document, and then we're going to scrub it, move some stuff around, and just give an example, right? So here's some data points and the various columns showing data that exists inside of this data set. So if we plot that, this basically is the historical data that's in the data set showing energy demand I'm assuming, sort of megawatt hours over the course of some number of days in that time period in December of 2018. So now we can use the time series model. This one uses the R2 model. We can use zero-shot inferencing on it and create ourselves a forecasting pipeline using that model and the columns that we mentioned earlier, and ask it to give us a forecast. So basically, it didn't work. I don't know what these nans are, but let's see if the next step works. Oh, okay. So it plotted it out, and of course, this should look like the information we saw previously. And then the red line represents the current time when we started the forecast. And then these are the predictions made by the model. And you can see they basically live in the same shape space as the prior historical data. So there are several time series recipes inside of the time series cookbook as part of the IBM Granite community. And as I mentioned, we just got a new one that came in earlier this week, I think, on retail sales forecasting. So we're going to continue to look to expand some of the examples that we have in the time series side of things, because it is proving to be a very popular member of the Granite family of AI models. All right. Any questions on time series? It's a bit more data sciencey than sort of language model stuff. In fact, I'm not entirely sure I understand all of the data science behind it, but it is very intriguing and very popular.
I do not see any questions.
Okay. All right.
So keep going, and we'll
All right.
oh, wait, oh shoot. I think one might have just popped in, but I lost the window.
All right.
Q&A. Yeah, just one question, BJ, is are Granite models available as ONNX files?
I do not believe that is the case. We have them up on Hugging Face as safe tensor files. We also put up now, like as I mentioned, we're now putting up GGUF variants of those up on Hugging Face as well. So if you need an Onyx representation, you're probably going to need to use some conversion tool to get it in that shape.
And then one other question from Miriam. can you use Granite to build a local ChatGPT, answer prompts like explain this code, and use the as a base for coding assistant apps?
Oh, definitely, definitely. We have an article tutorial we wrote where we used the Visual Studio Code with the continue extension to connect it to an Llama running Granite model. And so inside your IDE, you can ask it those sorts of questions. You can chat with it and ask it about some code and that sort of stuff. So it's a cool demo showing you how you can do that locally. Basically make your own AI coding assistant.
Um, the other question is, are your Jupyter notebooks, are you running them locally or within like the cloud, like watsonx.ai?
In what I'm doing here, this is just running locally inside of Visual Studio Code. So it's fired up a Python IPy kernel to run the notebooks. So it's all part of the extensions that you can install in Visual Studio Code.
All right. I think we caught up on the questions, so keep on going.
Great. All right, so we're in the home stretch here. This is our final lab that we're going to look at. And so this lab is basically going to be using the Granite code model. So in addition to the Granite 3 architecture models, language models that are out there, we also have some Granite code models of some different sizes. We're working to improve the code capabilities of the language models. But at the moment they're not necessarily on par. So this is going to use the Granite code model in this example. So this basically again uses our select a model code where we basically look to see if Ollama is running. If so, we can use Ollama. Otherwise, we're going to use replicate for that. So maybe we should be brave and fire up Ollama to see if it works. So let's run Ollama serve. Okay, so I've got Ollama running over here on my system. If I open up another window, I can see a list that I've got a bunch of different models I pulled down. And in particular, I do have the Granite Code 8B model available. So now when I go over here and run this, it's going to find the Ollama server. And it found the model there. And so we're going to end up using Ollama to run it now. All right. So now this particular example here basically is using some prompts, it's going to ask the model to write some bash code. And of course, every operating system is different. And all the commands on them have some slight variations in what kind of arguments it takes and how you do things. And so what we're going to do here basically is figure out what our operating system and what our shell is. And so this example, we are Mac OS and we're running bash. Right, so we have a pretty simple question here, which is basically show me a bash script that looks for files in the current working directory that have been modified in the last week. And of course, make sure my script is compatible with my operating system. So if we run that here, and of course, this is going back over to using my Ollama serve to support the model, to run the model. So it takes a little longer because it's running locally as opposed to remotely on replicate. So this gives me a little bash script with an explanation of how it works. So let's see if it worked. So we'll copy that into the clipboard. We'll go down here and paste it in and see if it works. And there we go. It printed out 4 files. They all seem to have been changed fairly recently. And shockingly, there are all these recipes that we've been showing off here. So that seemed to work, right? We did a 0-shot prompt to the model, asked it to write us a bash script, and it gave us a bash script that actually seems to do what we asked it to do. You can also do few-shot prompting with Granite code. So this is a sort of variation on that. And of course, this is an example where different operating systems commands have different flags, right? So the stat flags are different on Mac OS than they are on other Linuxy operating systems. So we have a bunch of examples, some shots to put into the prompt. And now we're going to, using the LangChain support, we're going to assemble a chat prompt based upon those examples and see that we're ready to go. And so now we have this completed prompt. We're going to ask it a similar question that before. And now let's run our model. All right, so this looks surprisingly like the example we had before. So basically, this is chatting with the model, asking it to write some code for us, some bash things. And of course, sometimes you have system prompts so you can add in if that can improve the results. So this is basically the same thing with a system prompt. Running it again. And we get a slightly different example here. So basically that's, just another example of the kinds of element or parts of the Granite model family. Coding is, of course, an important part. We have the Granite code models in a bunch of different sizes available. We're working to improve the code capabilities of the Granite 3 language model family. But there's still some features to be added to continue to sort of fill out that space in the language models. So the code models still have their use. And that's pretty much wraps up what I had to talk about today, right? We've gone through some charts. We talked about Granite. Why is Granite interesting versus other AI models that you might be familiar with? We talked about the family of Granite models and the different capabilities that they have. And then we went through some labs, some examples of using different use cases with the different elements of the Granite model family. So I think we can wrap it up. I encourage you to go to the Granite community. You can see there's a short URL there and even a nice QR code if you want to hit that. This will take you to the Granite community where you can get access to all of these various recipes and whatnot, and to play with that. We forgot Granite Vision. No, we didn't. Unfortunately, well, the Granite workshop that we use, right, as I mentioned, we try to make sure all the examples can be run locally on your system using Ollama as well as in Replicate. And it wasn't until just today that I saw that the version of Ollama that supports the Granite Vision models went left beta. So it's there now. But so we'll have to update we may go back and update the Granite workshop to incorporate the vision model into the examples.
All right. So we have one additional question, BJ. What do you recommend in order to add additional knowledge or rules to a Granite model? So I guess that's probably fine tuning.
Right. I mean, obviously, you can use a RAG situation, which doesn't really add knowledge to the model, but it makes it available to the prompt. Fine tuning, right? You can, of course, use your favorite popular fine tuning mechanism. The other thing we have is InstructLab. If you're familiar with that, it is a technique for doing some fine tuning based upon exploiting the capabilities of a teacher model to generate synthetic data. So some scenarios it can work well in others not, but it is sort of somewhat compute intensive because of the use of the the teacher model to generate synthetic data, right? That's a lot of inferencing. So if you already have a fine-tuning data set you want to use, you can just use any traditional fine-tuning technique on Granite. And because it's open source, what you fine-tune into your model is yours.
Well, I think that covers all the questions I've seen. Yep, I think we got them all. So BJ will be running a workshop at All Things OpenAI next Monday, or 2 Mondays from now on the 17th. Thanks for everyone for coming. I mean, it's great to see. I think we had over half of the people stayed for the whole webinar, which is you know, that's saying something. That's well above the average. So thanks everyone. We will see you soon. Thanks, BJ.
Bye, everyone. Thank you for coming.
Thanks, PJ. See ya. Thanks to everyone.